Look at the dashboard of a modern private cloud. It's clean, organized, and updates in milliseconds. Now look at the actual physical source of that data, a dark, grease-stained manufacturing floor built in the 1980s. Over half of the manufacturing industry utilizes smart sensors today, yet the physical machines doing the actual heavy lifting are routinely more than 20 years old. These machines operate on older, fragmented operational technology protocols. They speak languages like Modbus or Profibus, which are completely illegible to a modern IT network. Connecting this unencrypted legacy hardware directly to the public internet or a cloud infrastructure exposes an entire production line to catastrophic security breaches. Modernizing this infrastructure requires dealing with physical, analog realities. Systems engineers have to interface directly with vintage control panels, worn keypads, and serial ports. The challenge is highly variable across the factory floor. The internal wiring of an old lathe is entirely different from the sensor array on the material hopper of an injection molder. Because these physical interfaces are so inconsistent, software updates alone cannot bridge the divide between legacy operational technology and modern information technology. For years, the default modernization strategy was rip and replace, completely substituting older assets with new internet-ready machinery. This approach requires massive capital expenditure. If the new machines fail to meet production expectations, the entire investment results in a highly wasteful negative return. The alternative is the wrap and extend architecture, or augmentation, which adds third-party connectivity tools directly to the existing equipment. By deploying localized sensors and network translators, factory owners can upgrade specific capabilities incrementally, keeping costs low and deployment fast. At the center of this architecture is the Edge Gateway. It acts as the physical translator between the old machine and the new network. Instead of sending raw, vulnerable data to a remote server, an Edge Gateway processes it locally. This neutralizes the compatibility issue while securing the data right on the factory floor. The gateway provides the physical bridge necessary for legacy machines to join the modern cloud economy, avoiding the expense of a complete factory overhaul. A specific hardware solution built for this exact problem is the IIOTCore Node gateway. During the ingestion phase, fragmented operational data enters the device physically, routed through the green terminal block or the Ethernet port. Once ingested, the gateway performs the IT handoff. It translates those older protocols into the secure MQTT or REST data streams that modern cloud environments require. This flowchart maps the physical process onto a logical network. Modbus RTU data enters the gateway and exits as an encrypted MQTT stream. Processing data at the edge keeps sensitive metrics localized. Secured data is routed only to a private cloud, never leaving the manufacturer's jurisdiction. The marketing positioning for this hardware is straightforward. It is explicitly sold as the bridge between legacy machines and the cloud. This single device represents a much larger movement in manufacturing, the push toward hardware that is secure, localized, and sovereign by design. To understand the origin of devices like the IIOTCore Node, we have to zoom out and look at the entire Indian hardware ecosystem. Right now, India is undergoing a structural shift. Long recognized as a global hub for software services, the country is actively building a deep tech and electronics manufacturing base. Private capital is heavily backing this shift. There are currently over 250 venture capital investors explicitly targeting the Indian hardware sector. This horizontal bar chart ranks the most active of those funds. Firms like Bloom Ventures, Inflection Point Ventures, and the IAN Group lead the market by their sheer volume of hardware investments. Rather than funding consumer software applications, these funds are injecting capital into complex physical infrastructure, deep tech engineering, and sovereign supply chain networks. The state provides the scaffolding for this investment. The government's Building New India framework explicitly targets structural reform, resilience, and industrial transformation. The emergence of local hardware solutions is a direct consequence of this alignment. Private venture capital and national industrial strategy are pushing in the exact same direction. The primary driver behind this domestic manufacturing push is the national policy of Atmanirbharta, or strategic self-reliance. The union budget for 2026 to 2027 heavily subsidizes this goal. It allocates massive resources towards scaling domestic production in strategic, labor-intensive sectors. This includes launching the India Semiconductor Mission 2.0 and expanding the electronics components manufacturing scheme with a 40,000 crore rupee outlay. This line graph visualizes the result of these policies. Over the last decade, domestic electronics production value climbed from 1.9 lakh crore in 2014 to 11.3 lakh crore in 2024. The human dimension of this industrial expansion is equally substantial. The electronics manufacturing sector alone generated roughly 2.5 million jobs in that same timeframe. This translates into physical scale. Facilities are running full assembly lines with clean rooms and specialized workforces dedicated entirely to hardware production. India's manufacturing renaissance relies on hard data and firm institutional support to secure a dominant position in sovereign technology. This localized production ultimately intersects with the global supply chain, where heavy manufacturing and international logistics overlap. Modernizing legacy machinery scales far beyond the individual factory floor. It is a critical requirement for the resilience and efficiency of the entire global trade network. Sovereign edge computing layers security over these vulnerable machines, allowing manufacturers to safely integrate their analog systems into international cloud networks. As this integration accelerates, the Indian economy transitions from a service-oriented exporter into a high-value hardware producer operating at a massive scale. The technology bridging old machines to modern networks is the very same technology bridging India to its future as a global industrial leader. Sovereign, edge-based hardware design offers the most secure, cost-effective method for modernizing legacy infrastructure. As nations prioritize strategic self-reliance, the localized nodes connecting a mechanical past to a digital future will form the foundation of global industry.